Welcome to Building Toronto's Skyline, a podcast exploring the current state of Toronto's construction and development industry from a unique construction perspective through engaging and entertaining podcast interviews with the many stakeholders in the industry. This podcast is brought to you by Fusion Corp, a construction management company. Here's the founder and CEO of Fusion Corp Developments, Inc., and author of Building Toronto Skyline and Battle of the Skyscrapers. He's the host of this podcast, Nick Ainis.
All right, where's the applause? Oh, I love it, even though it's fake. Anyways, how you doing, Mike?
Good to see you, Nick. Nice improvement. I saw outside it was above zero.
Yeah, but it's cold. It's below zero here in the basement. So.
I'm trying to keep you awake, you know. When you go to you go to Radio City Music Hall, it's always cold, and that's to kind of keep things alive.
Yeah, sounds good.
You're in the big leagues here, Nick.
Okay. Thanks for reminding me. Okay, so
speaking of the big leagues,
are we done or what?
Well, we always have a little back and forth for a few minutes, and then we have on our special guest.
Don't forget about Brad Bradford. We're having this huge event for Brad.
Well, tell me about this, Brad Bradford, a previous guest on Building Toronto Skyline.
Yeah, we're doing a live event for Brad Bradford, and we're going to be, details to come out shortly. It's to hear all about what the future mayor of Toronto is going to bring to the development industry, and you're going to have a chance to hear our conversation live. Building Toronto Skyline live. This
is really impressive because Brad was a guest on your show.
And you're coming too.
I'm going to be there for sure. I got to record it. I got to record it. So you've just made a prediction that we're going to pull this clip and bring it back after the mayoral election in Toronto. But you're saying Brad Bradford's going to win the election.
He's going to win
because of your help.
Because he's best suited for the job. That's why.
Okay, so stay tuned, everybody.
Help. So that's what we're going to do, and it's going to be an amazing event, and you're going to get a chance to talk to Brad directly.
Okay, I can't wait to witness this.
We're going to start plugging that. We're due for a Toronto Mike. I know, here, and then we're going to do a Toronto Mike show, too.
Maybe we should get Brad as with you on Toronto Mike.
Yeah, we should. Hey, that could be a good one.
We'll bring him in.
We'll see. All right, so let's get on. We've got Oliver David from Oliver David Krieg. Is that the way to pronounce it? From Intelligent City. So do they call you OD? Is OD for short?
It is.
Okay. What do you like better, Oliver David, or you like OD?
OD is good.
All right. I like OD too.
OD's the OG.
So we got OD from Intelligent City, and focusing, and primarily your main focus is mass timber production, and you're based out of BC, if I'm not mistaken, and but you're working all over Canada, I would imagine. Is that right?
That is correct.
And you're into the we're doing things that we haven't done before. Mass timber is really catching on. There's quite a few projects that are being done in mass timber. I personally have not done. I've done almost every structure possible you can think of, except mass timber. So I want to really, take the time out to learn a lot about this. It's going to be great for the audience, and we're very excited to have you here too. So thank you for joining.
All right, let's do it.
Okay, so let's get into it. So let's. You have an interesting background. You're from Germany, right?
That's true. Yes.
Can you do the whole show in German or what?
You want me to?
No, I don't want you to. I won't be able to understand it, but it's okay. But so I understand that you have an architectural background originally, and you expanded from there. So tell us a little bit about how you got into this.
Yeah, really sideways in a way. I studied architecture in Germany, and sort of typical architecture program, which is maybe a whole other discussion, right? Everyone is learning to be the next superstar architect. Everyone wants to design the next museum and, TV tower and the biggest bridge in the world and whatnot. And that was going quite well. And I think I still have a lot of design sort of in me. I really want to work on design and make things pretty, which I think is always very important when whatever product you develop, it has to also look good and function well.
Yes, of course.
And then halfway through, I got into robotics and computational design, they call it. So programming the design process instead of doing the design process manually, automating design processes. And we had a industrial robot arm at our school, and I started using it for CNC cutting and things like that, and started programming it, and that just became its whole research field, which many architecture schools and engineering schools are still working on, in inventing or innovating in manufacturing processes. How can you streamline the data flow from design to manufacturing? How can you make it as flexible as possible? And all of these things. And that sort of got me into sort of an academic career. I ended up doing a PhD in that field. And then in about 2017, I taught a course at UBC in Vancouver, and ended up meeting the founder of Intelligent City, Oliver Lang, also an Oliver. So you can see where this is coming from.
Yeah. Well, that's amazing. So you did your research in Germany, and then you, by chance, came to Canada. Do you miss your home? Do you miss your home country?
Sometimes driving is better in Germany.
It's better. Okay. Better vehicles, maybe. Well,
maybe too, yeah. But it's funny. There's a lot of Germans in the timber industry. I realized lots of Germans helped. Swiss helped build the Canadian railways. Germans are everywhere in the timber industry and in engineered wood. And I kind of keep running into people from Germany that have lived in Canada for 30, 40 years, and it's really great. And I think it's needed. It's a bit mix of different backgrounds that helps mass timber proliferate.
Amazing. So tell us about that day you met the founder. Oh, it's Oliver Lang, you said, right?
Yeah.
Tell us about that day. Like he was. He came to the course, or how did you meet him?
He did, yeah. He was my student.
Oh, he was your student.
And
okay,
yeah,
he's younger than you.
No, he's older.
Oh, okay.
He's been in the industry for a long time, but he had this very much ahead of his time. I think he and his co-founder Cindy Wilson, they had this idea of changing the way we build housing and changing the typology of housing as well. Here in Vancouver, they had built, back when everything was just 1-2 stories outside of downtown, 10, 15, 20 years ago, they had these ideas of building 4-story, courtyard style buildings to get more units into a 33 or 50-foot lot, and making it as livable as possible. And they had quite success with that from a design perspective, but never were able to really replicate that. And so for a long time, he had thought about, can we use prefab? Can we systematize this somehow? And so he got interested in robotics, and I happened to teach a course on robotics in sort of manufacturing and construction at UBC. And afterwards, he took me aside, and he said, "Let's go for a coffee. I have this idea for the company, and I want you to join us." And from my perspective, I had learned a lot in my academic work about how to standardize a process, but have a lot of flexibility in its execution. Because in architecture and in construction, you need flexibility, you need design customization.
Yep.
Every building is different. You can't rubber stamp a building. That's not the product. The building isn't the product. It's the underlying process that allows you to replicate it, but then change the design every time you do it. And so my perspective was always, data flows, how to allow for design flexibility, very much automation focused, design automation, manufacturing automation. And I didn't actually think that could be applied in the real world at that point. That's 2017. And then he talked to me about this idea of standardizing this sort of building platform for multifamily housing. And that's when it clicked for me. And I said, wait a minute, I've been doing this for 10 years. I can apply this in the real world. We can build buildings, sure, they're all rectangular and maybe sort of boring, quote unquote, but there's a lot of flexibility in there as well, and a lot of of what I had studied and learned is very applicable. And then it was time for me to finish my PhD anyway, and so I moved to Canada, and we started the company, and I started as CTO, so I was responsible for the technology behind all of that, and that's how we operated for the next 5, 6, 7 years.
That is an amazing story, and very lucky that you came across Oliver Lang, and
absolutely,
yeah, and that's those are stories that we want to hear about, and it's a story of success. And so that's so your how was the beginning when you were in there? How was it starting out? Did it take a long time to get your feet off the ground? And I mean, the setup must have been quite intense.
Yeah. 5 guys on a laptop sort of style.
That's a great way to start. Do you look back at those years and say, hey, wow, that was incredible? That was the most fun that we had back in the day.
Yeah, yes and no, because I'm not because I didn't enjoy it, but because I think we were quite naive. Yes. And I think that's needed too. And I think especially in this industry, if I had known back then what I know now, I probably wouldn't have joined. And then it wouldn't have happened, right? So I had to have the naivete of saying, well, I'll pack up and go to Vancouver and we'll build something, and then just dive in and try to make it work. And we didn't know much about mass timber back then either. 2018, mass timber had only been allowed in Canada for 4 years,
right?
And so we looked up, how do the details work? How can we systematize this? How can we manufacture components so that we can deliver them on site? And that took quite a long time, and we came up with a lot of different ideas of how manufacture the building components in the factory. And we went through a seed round, and then ultimately we found a small factory space in Delta, just south of Vancouver, south of Richmond, and it was for a long time, for 3-4 years. The question was always, what comes first, the factory or the project? Can we get a project and then we have proof that we have demand and then we build a factory?
I don't think you can.
Or is no one going to give us a project because we don't have a factory, right? And so we decided we need a factory first, even if it's only half set up. But we need to show that we are serious about what we're doing. And so we got a factory and put some robots and some equipment in it and tested the process. And it took quite long. Like really, I think everything took twice as long as we thought. But I also think back, I saw an old presentation from some Tesla guys, and they basically said the same thing, right? In the beginning, there were 7 guys on the laptop, and none of them had any experience of building cars.
Yeah,
and maybe that's needed to like not be over encumbered with how it's being done.
Reality,
right?
Yeah. So I mean, that's the thing about being a dreamer, right? An entrepreneur, you're a dreamer at first, and then you run into all the difficulties along the way, and then you become more realist. But then you still have that drive and that passion, and you're continuing to solve all the issues that you have to solve along the way to make it successful. So yeah, but that's amazing.
Absolutely. I think you have to have the vision, and that's very important to get going. But then execution is even more important, right? And really making it happen. And especially in our industry, so much depends on you doing things well and collaborating with the industry, collaborating with your colleagues and with the trades and the consultants. Our industry is so intertwined and so connected. You can't go in there and just say, oh, we are disrupting everyone, because then no one will want to work with you.
Yeah, I don't think you're disrupting anything. Well, you're certainly bringing something new to the industry, that's for sure. And are you one of the major players out there in the marketplace right now? Would you categorize yourself in that way?
Well, so we're not making mass timber; we are using mass timber, right? So there are 4 mass timber suppliers in Canada right now, and maybe a 5th soon. And I'm sure there will be more in the future. It's a rapidly growing market. So we are taking mass timber, we're making it into prefabricated building components.
Of course, yes.
and amongst those prefab companies, I would say there are many and also big ones that do a lot of single-family housing, low-rise construction, but that's oftentimes with stick frame, right? Timber frame construction, 2x4s, 2x6. And there are a few.
Yeah, but that's a different market altogether. So you're not
exactly.
you're not in that market, obviously. So
we're not
putting that aside, because we've done a lot of wood panelization for multi-rise, multi-unit residential buildings. So, but in terms of mass timber, it's a very unique product, and it mirrors the style that we've had around for hundreds of years, so to speak, in Canada. All the older buildings from the early 1900s were made primarily, or a lot of them were made out of mass timber as well. So, and exactly. we did a building conversion that was of mass timber, and we checked fire ratings and all that kind of stuff. So it was, and I'm sure you're doing something. So, well, obviously you're doing that to some extent as well. But so are you one of the leading prefab suppliers out there in this day and age?
As far as we know, we are the only ones who prefabricate building components made of mass timber for high-rise construction.
Okay, good to hear.
Yeah, I think even in North America, and it's honestly, I don't know why, because at least when you think about prefabricated walls, prefabricated and envelope walls, using stick frame, using steel studs, using mass timber, it's not a big difference. Everything else is the same: the cladding, the insulation, the windows, same process.
Yeah.
So for us, it was pretty straightforward to choose mass timber as the base material, because it's very easy to machine, it's very easy to handle, it's lightweight, it's sustainable. All of these aspects come together, and the rest is just figuring out how to prefabricate components and how to make them as flexible as possible, and how to make them easy to install. That takes a lot of time, of course, and a lot of effort. But the fact that it's mass timber is sometimes overshadowing. And sometimes it's good, sometimes that's bad, right? We love the material. We want to use it, want to see it everywhere. But it's a new building material.
Right.
And so people are quite hesitant to use it as well sometimes.
Our industry is slow to adapt, slow to learn, slow to, we're always thinking about risk, and cost is a big factor as well. But is this very similar? Like, I'm going to give you an example. So we've done a total precast build before. A couple of times. So we do all the columns, we do all the shear walls in concrete, and all the floor assemblies are hollow core precast, and we do the entire superstructure that way. And then the envelope too is of precast material. So is your system kind of similar to that? I'm not saying that it's directly similar, but you have all the building components to do the superstructure. And do you do the exterior as well? I was just curious about that. So,
yeah, exactly. The exterior walls are really our main product, because they are so completely integrated. So you have the mass timber frame, the membraning, the insulation, and the cladding, and the windows. It's all made in the factory.
Oh wow, and that's great.
Those panels hang from the structure of the building, so it's a curtain wall style system.
Oh, amazing.
They hang from the structure, so they're non-structural, and they have gasket systems all around that are quite complicated, or they were difficult to engineer, because what you don't want is you don't want to have to access the building from the outside. You want to plug these panels together, and then it's done. And that's sort of the main component of this. So you get truck-sized panels. They can be up to 28 feet long, and you hang them from the building, and you enclose the building basically within 2 days.
Yeah, so it's similar.
One floor, 2 days. So within a few weeks, you can just wrap the building up and put your roofing on. So that's the main advantage of using a prefabricated system like that. So it's a little bit more advanced, I would argue. Yeah. Also, wood is 1/10 of the weight of concrete. Mm-hmm. So if you build your structure and your envelope out of wood, you reduce the weight of the building by about half. Wow. And that also has a huge effect on the foundations and the transfer slabs and the cores for lateral. The cores are still concrete, and we actually like to use precast. We like to use precast concrete panels to build the core just as quickly as the rest of the structure and the envelope.
Yeah, because if you do it with forming contractor, it takes too long. Sometimes it takes too long. It's messy. And
Exactly.
yeah, that's a good idea. So your exterior walls, what are they like? Are you using mass timber for that, or are you using like a conventional 2x6
No,
stud wall?
yeah, no, because we want to go as high as possible. We are using basically it's a 3-ply, 105 millimeter mass timber panel. So it has a certain fire safety already, and if you want to use it as your zero lot line wall, you put drywall on top, and then you're totally safe. And that's the structure of the panel, right? And then you can attach everything to it. And because it's a solid piece of wood, it's very easy to put your membrane on and to screw in the cladding and all of this stuff. So that's one advantage of having the panel. And then the kind of cladding we are using also, that's the trick of prefab. How do you put the cladding on in the factory and then align it on site so everything fits together properly? That's the secret sauce to make everything work.
So do you do so it's very similar to a precast panel then? Would you say that it's your interior walls, you do them out of stud and you have to put you blow in your insulation, or you lay your bad insulation in vapor barrier? Is that the idea?
No, it's a solid layer of mass timber on the inside, and that could be your inside surface, and then you put insulation on the outside.
Okay, and you get
so it's rigid exterior insulation. Yeah.
Oh, so I don't have to put any insulation on the inside.
No.
And what about drainage of the envelope system? How was that handled?
Well, just the way you do it with every wall assembly. So you have the timber layer, that's the inside. Then you have a membrane. Then you have exterior insulation. Then you have cladding. Between every floor, you have gaskets and
Do you caulk panel to panel and stuff like that?
Well, just in the corners, because we have a gasket system that connects the panels, and that was actually tested for Passive House certification.
Okay.
So it's extremely water and airtight.
Okay, so you don't have to caulk the joints or anything like that.
Yeah, and in the joint where 4 panels meet, there's some caulking applied, but
okay.
This is made to last. This is made to be high energy efficient, made to last. Definitely a high quality panel, but we are competing on a price perspective. We are competing with window wall systems.
Oh, excellent. So you're doing the entire superstructure. You're doing floors, walls, and columns. And tell me a little bit about your system there.
Yeah, so concrete core in high rise, that's still needed, concrete or steel.
So my elevator shafts, my stairwells, any shear walls that I might need for lateral support or something like that, if necessary.
Yeah, normally you don't need shear walls, because you basically use the core for the lateral strength, okay. And then you have straps or drag struts, they call them, that tie the floors back to the core.
Okay.
And then the floors are made by panels, mass timber panels. And what we are doing is we're taking the mass timber panels that come out of the mass timber factory, and we add a raised floor to them. So we are adding a cavity space so that we can put services inside of them. So again, it's a question of integration, right? How many things can we put into our components so that you don't have to do it on site, while keeping it flat packed, right? We're not going volumetric modular. It's all flat packed. And so our floor panels have this cavity space where we can put mechanical ducting for the heating, ventilation, and electrical conduits for the electrical distribution. And so we take away basically a lot of that very tedious work from on-site, put it in the floors. We have our columns. They're now steel. They used to be glulam. Steel is easier. Steel is cheaper as well, and you hide them in the walls anyway. So you have steel columns, big mass timber floor panels. And again, because they're so big and you have so few lifts, you can set up a floor in 1 or 2 days.
Wow, that's pretty amazing. So, yeah, because historically with, call it your precast or something else, you would have you'd core through it and you do all your plumbing and electrical inside the unit. And you don't have to do that here. Is that what you're saying?
Yes, well, first of all the penetrations are pre-cut. That's pretty easy, right? So all the plumbing, all the vertical stuff, It's all pre-cut, all aligned.
Yeah,
That's
so
super easy. And then
do that during
mechanical and electrical.
Yeah, you do that during the shop drawing process, I would imagine.
Exactly.
So you get the engineers to identify all the shaft areas that you need to, or all the major openings through the slot, through your product, and so on and so forth. So that's pretty interesting. So most of the rough-ins are kind of done with the mass timber product.
Yeah, exactly. And it's not that much more planning. Obviously, you do need to have a few loops where you have to ask the engineer, is this correct? Are you okay with the penetration being here or there, and so on. But that's about it. It's really not a big deal. And that's the funny thing, because the plumbers didn't believe us. But when they came to site and they looked down the hole and they saw all the way down, all the holes aligned all the way down to the ground floor, that's when they were, oh, I can see this is working, and I have less work to do now because everything is already prepared for me.
And you even do duct work too. Is that what you're saying? It's all on the floor? Is that?
Yeah, the ducts go in the floor. So you have your ideally, I think, and we're still figuring this out, but I think ideally a decentralized HVAC system. So you have an ERV or HRV in the apartment.
Yep.
So you drop that in, you plug it into the floor. The floor distribution is already taken care of because we do that in the factory.
Interesting. And what about venting and all that stuff? So you have to vent like for kitchen exhaust and stuff like that. Does that go up into the floor above? Is that the plan?
It goes down, actually. Yeah.
Oh, it goes down.
Yeah.
Wow. Okay. And how does that work? You go up and down? Because the vent is usually above the stove or something like that. And
yeah, so that depends a little bit. We're still figuring out exactly what the best distribution system is, because sometimes the bathroom is pretty close by. There has a vent on the top as well, right? And then you just take a small portion of the ceiling. That's a dropped ceiling. It's a small bulkhead between the bathroom and the kitchen. That's where the exhaust comes. Then it goes down into the floors. Or you have the vent system on new stoves that vent down. I don't know if you've seen those, right? That take the air behind the stove just down immediately.
Interesting. So, and what do you do about like maintenance and repairs? Let's say I get a plumbing leak or something like that. There's something that just quite doesn't work out, and you have to fix something. Do you have to cut through the ceiling or the ceiling below, or how does that work?
Yeah, the good thing is you can with a normal saw, right? You don't have to cut concrete. Otherwise, it is very similar to concrete. If you have a leak, you have to open up the floor. You have to look at it. You have to dry it out. But you can. That's the nice thing about mass timber is it's glued timber, right? Engineered timber. It's glued together. But the glue doesn't dissolve in water, right? It's a very, very strong glue. And so if you have a leak inside the floor or between floors, you can open up the floors. You can cut holes in, you can look at them, you can cut holes to blow hot air into it and dry it out. And that usually is, it's a local problem. You can fix it locally. That's what insurance companies are usually asking as well, right? It's fire, obviously, it's always a question, but water damage is usually the biggest insurance problem, yeah. And that's easy to solve.
Because, like, in most cases, in like a typical condo building or multi-res building, maybe you've got a drop ceiling, where that leak is, it's coming through the drywall, and you're able to find it easily. Mm-hmm. So you cut the drywall. Well, I mean, cutting drywall is easy too, but you cut the drywall out, you find the leak, and then you fix, repair, patch, and repair. So I was just wondering if everything is in the floor, then you have to be able. How do you find the leak exactly where it is? Because water is a funny thing. Once you have a leak, it's difficult to spot exactly where that is. How do you determine where that might be? Is it trial and error?
No. So we're not putting plumbing in the floors.
Oh, you're not putting any plumbing
because of that problem, issue. Right?
Okay.
Yeah. So plumbing goes vertically, just through the floors vertically, and then the horizontal distribution happens very compacted where the bathrooms are. So where the bathrooms and the kitchens are, you will still have a dropped ceiling. Yeah. But otherwise, so basically 70-80% of the ceilings are just clean, just clean wood. and you can leave it as wood. You don't even have to drive over it, right? So it's very easy.
Yeah, except for plumbing any drains or anything like that pass through there. Okay, fair enough. All right, I'm learning. So I'm going to teach a course after this. But so tell me some of the buildings that you're doing on. Is your product like, are you doing houses too, or are you just focusing on mainly multi-res buildings?
Yeah, it's really multi-res, and it's really mid-rise, high-rise, right? Because our walls are this sort of curtain wall style system. We have columns. You can replace columns with load-bearing walls when you do 5 or 6 story buildings. That works as well. But when you go lower, it's just a different product, right? So if you think about productizing buildings or productizing the components of buildings, you really have to differentiate between, ADUs, single family, multiplexes, and then you go to like, 4-story multifamily, and then 5, 6, and then you go to high rise. And we developed this for high rise. So our first building was actually in Vancouver in East Van for the BC Indigenous Housing Society. That was a 9-story building with 80 units, an affordable housing or affordable rental project.
Yeah.
And we provided the envelope, for the 122 envelope panels, all as big as a truck, passive house certified. And our last building was at 230 Royal York Road in Etobicoke in Toronto, which is my background here, which is also a 9-story building, a 60-unit rental, market rental project. So it's really larger scales. And the projects that are coming up are 200-unit apartment buildings, 400-unit apartment buildings, like larger developments where you have a bit more repetitiveness,
right?
And you can really have efficiencies in manufacturing and in construction.
And how high can you go with your product?
So the structure can go up to 18 stories by code. The code, there's conversations that the next code update will maybe allow to go to 24 stories, I've heard.
Right.
So that's really exciting. Mass timber, we have to get used to the material. I understand engineers have to get used to it. The code has to get used to it, right? You have to show proof that it works. And there are a few examples out there that are 24 stories. But the envelope, because it's non-structural, can actually go on any height of a building.
Right.
So the envelope is an independent product in a way. And if you have a concrete building and you want to clad it with a better envelope, and it's 30 stories or 40 stories, we can do that.
So when you're doing, so back to the floor is very interesting because you get your fire rating, but you have all your duct work in there and all your electrical work. Is that so? Are you putting conduit in there, or are you running wire as well? Just conduit, empty conduit.
Just conduit, because you have to connect it to the walls, right, to the interior walls later.
Right. Okay. I'm trying to get this all in my head so I can figure it out. It's pretty amazing. That's really great. And so you're building almost the entire building, all the cladding, everything along with that, and that's you're using. How fast can you make this stuff in the shop too? That's pretty interesting. So let's take an example. How fast can you put up a superstructure envelope for, like, say, the Royal York project? Use that as an example. How long did that take you to do the entire superstructure envelope?
Yeah. So so far, so for those who have listened carefully, they would say, "Wait a minute, your factory is in Vancouver and you build a building in Toronto. How did that happen?"
Yeah.
That's a very good question.
Oh, well, you know what? I didn't ask that, but
well, let me stop.
You're smarter than me. Go ahead. Let's hear the story.
No, well, I mean, this is
answer your question first. How's that? Okay. Shipping containers, right?
I'm just saying it because obviously with that kind of setup, you're not going to be very fast, right? And we decided to do that because we wanted to enter the Ontario market, and we this time we decided not to build a factory first and then see what happens. Obviously building a factory takes a lot of money, and so we said, okay, we'll eat the shipping cost. We'll make it happen. We'll ship the components to Toronto, and we'll show that we can build a building superstructure and envelope. And once that is done, which it is now, that's when we go and we build a factory, when we see what the responses are. And the
Right.
responses are very positive, and we see a lot of interest, and we see big buildings coming down our pipeline. So there is really a need now to build a factory, which is great timing for us.
So
But
are you building the factory?
We will. Yes, so
Okay.
we are raising money actually to do that. Right
Okay.
now, we are looking for strategic investors who can help us do it. We have a lot of government funding, grant money.
Yeah.
So the government is really pushing, as you probably have heard, to support industrialized construction and prefab and mass timber.
Yeah.
So that's coming soon. We are hoping that we can be operational by early 27 and start
Exciting.
delivery of our next buildings.
Did you send everything by truck or same
Yeah, we
same
did.
way? Okay.
Yeah, truck. Because some of the panels were wide load. The envelopes are vertical, so they are extra high, right? They are 10 feet high, so your trucks have a higher height than what trains can usually do. So we shipped all of this stuff via trucking from Vancouver to Toronto. And our Vancouver factory is really small, right? It was always a pilot plant. It was a proof of concept, if you will. It wasn't meant to be a fully commercialized factory.
Yeah.
So we weren't able to really go as fast as we could, because install is faster than manufacturing, right? Installation, like I said, you can put a floor up in 1 or 2 days. You can put an envelope on a floor in 2 or 3 days. So if the factory was in Vancouver, in Toronto, and you had, let's say, a 10-story building, theoretically we could put that up in 30 to 60 days.
Wow,
and that's really the promise, right? But that also means we need a factory that's big enough so we can manufacture components that quickly. So what we are looking at now is a factory that will allow us to build the equivalent of about 1,000 to 1,200 apartments a year.
Wow.
So we can basically manufacture a 150, 200 unit apartment building in a few months.
So that's the idea, is to do everything in a few months. 3 months, 4 months. What's a few months? Just to give me a rough idea. 3-4 months?
200 units would be 2 months of manufacturing and 2-3 months of construction on site.
Wow, that's pretty amazing. So that's the future, isn't it?
I think so. And honestly, I think that if it's not us, it's going to be someone else, right? The challenge in this is not technical, right? We know it works. We've done it. We've seen the panels are picked up from the truck. They go in the building. It's done. Like in 5 minutes, the panel is installed. Yeah. That's not the problem. The problem is logistics, management, coordination, on-site, off-site coordination, right? You need to make sure everything is aligned. You need to make sure the site is ready. All the trades are aligned, right? It just takes a little bit more coordination, and obviously, more than what we were used to.
For me, that's the easy part.
Right, there you go.
Yeah, because I think we can take our precast experience and sort of apply it here. I'm sure it's going to be some like a learning experience, of course, but. Yeah. They're all very similar. You have to have the same type of approvals. You'll need all the information possible to run it through your drawings and stuff like that. But this is really, really cool what you're doing, and pretty excited to learn about this. And we have to try to do a building together. So is everything robotic in your plan? Is the plan for everything to be robotic? There's a human factor, I'm sure, in the component involved, obviously. Tell us a little bit about that. That's pretty interesting as well.
Yeah, for sure. At the moment, when we are talking about percentage, I would say we are about 20% automated. And this next factory in the GTA would probably be about 40% automated.
Oh, wow.
And it's small steps.
Yeah.
Because you need to test your assumptions, right? We are in a completely new field. This is not car manufacturing, right? It's not established processes. No one knows how to automate the production of building components. So we have to learn. We have to see where are the bottlenecks. How can we make this easier? The reason we automate is because we want to allow for that flexibility in design, right? So we want to allow every component you make can be different lengths, right? Different window positions. From project to project, you might have different cladding systems. So how do you systematize that so that you can actually allow for that flexibility in your manufacturing process? That's where automation really comes in. Software automation to produce all the documentation, but also robotics, of course, to just automate, where you place the cladding clips or the insulation, right? Or how to cut the wood. So we started with a few very specific tasks that the robots are doing. They're at the moment in our factory, they're mostly picking and placing. They're applying glue. They're cutting the wood. Sort of basic tasks. That's the nice thing about mass timber as well, right? It is heavier than what humans can carry. So it's really prone for using industrial robots that can carry 200, 300, 400 kilos, because they can lift that, they can put that in place, they can move the material around. But we are seeing lots of opportunities, right? Like I said, cladding clips, insulation, membraning, all of this stuff can be automated. And so we're just trying to make everyone in the factory more efficient, right? And that's sort of my overall argument is, well, if Carney wants to build twice as many homes with the same amount of people that we have, then everyone needs to become twice as efficient. You can't hire twice as many people. We don't have them.
Yes, exactly. So I guess your aim would be always to increase that level of robotic use and increase that percentage. Can you ever get to 80%, 90%?
I think 80%, that's the right number. And I'm saying that because, again, if you compare it, what people like to compare it against, right, is car manufacturing. Obviously, automotive is always sort of the peak level of automation. But a car factory makes a car sometimes every minute, right? I think Toyota has a takt time of 55 seconds. Most other car factories are a bit smaller. They have a car every 5 minutes. But when I said we are planning to produce 1,200 units, that means a component, like an envelope, comes out of our factory every 1 or 2 hours. So that's a factor of, 6 to 10 or maybe even 20x slower than a car factory. And that's okay, right? But that also means that every robot you buy has a lot lower effect than in a car factory, right? In a car factory, you add a robot, you have a takt time of a minute, you produce so many cars. Their automation makes a lot more sense, and you're really pushing, towards 80, 90%. But in housing, industrialized construction, I think we have to be more careful. We are not that automated, and that's okay, right? I don't need a factory that makes 100,000 homes a year, like a car factory. So the level of automation will always be less than what we see in car factories, at least for the foreseeable future. And the only calculation here is, can we increase efficiency? Can we increase quality? Can we increase design flexibility? And if so, then we will automate and we'll see where this takes us, this journey. But we have to be very careful of over-investing in automation, because at the end of the day, as long as we can make about 1,000 homes a year, it's a good factory. And the challenges are not automation. The challenges are delivery and building good buildings and building them on time.
Of course. Well, you want to look to the future, and if you can build these buildings efficiently, good quality, like you said, but you've got that production happening there as well. We're going to be able to pump out a lot more housing, and which is a great thing for everyone. Yeah. And I think that's definitely where the future resides. But so let me just, is there anything else? Like, okay, so just taking your, I know you're promoting your company and everything like that, but look at all the different products out there. So like I mentioned, total precast. I mentioned, you have wood, you have different types of product out there that's sort of this in the same realm, something similar in some capacity. Is there other sort of systems that you could ever think of in terms of other materials that you could use to also do in terms of automate as well? Just a thought. Yeah. I'm just thinking out loud here at the same time. But there are various competitors. So the panelization, the precast. You're doing the mass timber. Have you thought about other systems that could come into play for the future?
Yeah, absolutely. I said earlier that we're not doing volumetric modular, right? We're doing panelized. And so our vision of the future is a componentized building. Again, a little bit like a car factory, right? You're not building the front of the car and then the middle and then the back. You're doing the chassis, you're prefabricating the wiring, you're prefabricating the seats, the wheels, right? So we think about it the same way. It makes more sense to have more specialized suppliers that prefabricate components that you can then put together on site like IKEA. So we are doing the envelope, we are doing the superstructure, the columns. Now what's missing? Partition walls, right? So we would like an ecosystem of suppliers where there are other companies that make prefabricated partition walls with wiring included or conduits and the plugs and everything. We would like prefabricated bathrooms, prefabricated kitchens, prefabricated HVAC closets. So now you have 4, 5, 6, 7 different types of components that come on site and get put together. Now, like what I mentioned earlier about the speed, the components we are supplying can accelerate your construction by about 3, 4 months, maybe a little more. But if you have prefabricated partition walls and bathrooms and kitchens and HVAC systems, now you can actually halve your construction time. Now you're going really fast. And I don't think we need to do that.
Doesn't that slow you down to some degree as well?
I don't think so. I mean, you have to coordinate a lot, but you overall not, but by floor, yes, because you have to put our structure in.
Yeah.
Then you have to put the bathroom pots in. Then you drop the partition walls. Then you do the next structure.
Yeah.
Yes.
Yeah.
But overall, you're much faster because look, we finish the structure in the envelope, and then it takes another 5, 6 months for the interiors to finish, right? So that's the timing that you're saving on the back end of it.
Yeah, so this is going to be a very exciting product, and I think how did you deal with all the testing and of your product? That must have taken a long time to do. How do you find the municipalities are working with you? Is it a challenge to get them on board? That maybe the first one may have taken a lot of time. Tell us a little bit about that.
Yeah, so we were testing our components from the beginning, and we started internal testing, of course. And we also learned over time what do we actually need to test, right? Especially with the envelope. There are obviously regulations for that, and so when we engaged with testing labs like Intertech, they said, here's a list of tests you should be doing to get approvals. And we also got CSA A277 certification for prefabricated or modular construction, right? So that because these are enclosed components. So we did a lot of testing ultimately on the envelope for water, air tightness, wind, passive house, right? So air pressure differences, and we did that the first time ourselves, and then when we did our first building, they wanted to do it again, and so we did another set of tests for that. And then on the floors, we did a fire testing and lots of structural testing, of course. And ultimately, we have all these reports, right? And then we get the CSA certification for the components. And with all of that, we go to the city and we say, look, this is all tested, it's all to code. And there's a few things maybe sometimes that you need to push a little bit, but ultimately this, especially Vancouver and Toronto, we kind of see the larger jurisdictions are very open for innovation. And if they hear mass timber and if they hear, faster construction, quieter construction, fewer trucks, right? Fewer disruptions, they're very open to this. And we really didn't have much problems with that.
Interesting. So I would assume sound is not an issue either. You meet all the code requirements for floor assemblies, wall assemblies, and stuff like that. Yeah, that's
exactly.
Great.
Yeah, it's better than stick frame. Concrete obviously has some advantage because it's just so heavy, but it's oftentimes you can reach very similar levels.
Excellent. I'm very excited about your innovation here, and I think you're at the forefront of something very exciting. And I'm, you know what? Because I think skilled labor in general is coming down.
Yes.
It has been over the years. We've noticed a big difference. When I first started in the industry 20 years ago, we had great trades. We had people you shake hands with and they get the job done. Here, quality is coming down. manpower availability is coming down. People are going to be retiring from the industry. I don't see a future unless you're automating like you're doing in your with your system, which is very, very exciting. You're at the forefront. I want to join your company. Let me know if there's a job in there. I'm just joking.
For sure.
But,
let's talk.
But it is really exciting what you're doing. And what excites you most about the next decade of building innovation? I think your guys are going to expand big time.
Yeah, I mean, there's lots of challenges, of course, and real estate right now is in a difficult situation. So we see that too. Developers are very slow in making decisions, and we appreciate that. But we also know there's a wave coming, right? We can see it. The government is pushing. Yes. Developers are excited about this stuff. We are talking to lots of developers that see the potential. So what excites me is that what I just told you, that there will be an ecosystem of prefabricated components all across Canada, locally made, right? Canadian-made materials, Canadian-made, manufactured in Canadian factories, and then supplied to site. Seeing a 12 or 18-story building, a massive building, come together so quickly with such high quality is extremely exciting to me.
Wow, me too.
And I can't wait to see that at scale.
And I don't mean to get to. There's one thing I didn't ask you, and I think I just got to cover that before I leave. Cost. So how do you compare to other systems out there? What is your cost per square foot? Obviously, you're adding a lot of other elements that are generally not included in your cost, but do you does every estimate include windows, for example, or is it sometimes you're just doing the superstructure? Sorry, I should have got to that earlier, but if you could just give us a quick, before we close out, I think it's important for our audience to know how much does it cost.
That's the most important question, Nick.
Yeah,
you should have asked
of course. Yes. Thank you.
Asks.
You're always correcting me because you're German. That's probably why. So
I apologize for my Germanness.
No. Oh, you got a sense of humor too. That's great. But please tell me about cost, please.
Yeah, so it is at the moment, and we are at the very beginning, but at the moment we know already that we are competitive with concrete construction. So if you have a high-rise building, 10 stories, 15 stories, that you are planning to make out of concrete and a window wall system of some kind, I can tell you right now, will be just at the same cost, but we will be 3 months faster.
Wow, amazing.
And that obviously has monetary value. But we are also just at the beginning, and I can see our own costs coming down a lot at scale, right? We will build larger factories, we'll have better supply chains, more organized logistics. And that's why I'm excited about the future, is because we can see that dropping a couple % every year, and in 5 or 10 years, we'll be completely outcompeting on-site construction. So right now, the advantage you're getting is a faster building at a higher quality for the same price. And in the future, that'll also be cheaper.
Well, you know what? You really hit it home today, and it was a very exciting episode here today. And I love what you're doing. I'm on board. Are you ever in Toronto?
I am.
We're going to get together. How's that? I'd love to meet you face to face. Thank you so much for everything, Odie. Very exciting, super informative, and you guys can't wait to use your product one of these days.
That's great. Thank you so much for having me, Nick.
My pleasure.
And thank you for listening to Building Toronto's Skyline, a podcast exploring the current state of Toronto's construction and development industry. Proudly brought to you by Fusion Corp Developments, Inc. Please share, like, and subscribe. See you again in 2 weeks.